Hey everyone, Mr. Armitage here. In this video, we are doing an extra example from Chapter 4.4 of our textbook, factoring by greatest common factor. Okay, so this problem, we are factoring completely x to the third plus 10x to the second plus 24x. Now, the important thing to see when we are factoring by greatest common factor is that every term here, so the x to the third, 10x squared, 24x, they all have something in common. Specifically, they all have an x, because at least one x, or x to the first, because that's what is there. So we can take out an x from every single term. Now, what does that look like? Okay, well, we know from how multiplication and exponents and all that work that we can have x times x squared, right? That's x cubed, okay, plus x times 10x, okay? Because that's 10x to the second if we were to expand it back, plus x times 24, because that's 24x. Same thing. Now, since we have this x in all of them, we can factor that out. That x is a factor of all of these terms. So we have x times, okay, now the first part, which is x squared, plus the second part, which is 10x, plus the third part, which is 24. Okay. Now this is part of the way there. At this point, we need to see if we can factor this in here. Okay, this x squared plus 10x plus 24. And I think we can. Okay, this goes back to our quadratics. Now we actually have to factor, so we're not using our quadratic formula. Maybe. You can if you know how to use it. But let's try this. Okay, so we have our x box thing here, and we are looking for two numbers that multiply to give us positive 24 and add together to give us positive 10. Now, I think is relatively, it can be obvious that this would be plus 6 and plus 4. Right? Positive 6, positive 4. 6 plus 4 is 10. 6 times 4 is 24. Works out. So that means we have x times x plus 6 times x plus 4. Okay. Now we can't factor anything else because these are all unfactorable, right? We have this x here, the x plus 6, the x and the 6 do not have anything in common, and neither do the x and the 4, right? They are different terms. So this is our final answer. And there we go.